Hello and welcome to my YouTube channel. In this video, we are going to see how we can control the onboard LED of Nucleo-F446RE microcontroller board using the onboard switch. To program the microcontroller board, we will be using STM32 So let's start the video. First of all, we have to understand the step-by-step approach that we should follow whenever we write a new code. I have recommended you to download the user manual, and for this video, please download the schematic of STM32 F446RE microcontroller board. So to download the user manual, you can visit this link. And here in the search, you can just type Nucleo-F446RE. So let the website get open. Here you can just click on the search button and type Nucleo-F446RE. And it will open a new page. Here you can click on Nucleo-F446RE, click on the link and go down. Here you will see documentation, click on that and you can download user manuals. Come down and here please download the user manual of STM32 F446RE. Please download this UM1724. So click on that, it will open the user manual. I have shown this in the previous video also. So here you can scroll down and make note of the LED. So here LD2 is our LED2. And you can come down and here you can see on the figure LED2 is located somewhere here in the microcontroller board. And if we go further down, we can make note of the pin number to which LED or user LED is connected. Here you can see the LED is connected to PA5. So please make note of this pin number PA5, port A, 5th pin. Similarly, if you come down, button 1 or user button 1 is connected to PC13. So P port C, 13th pin. So this is done. And next, you will have to download the schematic. Again, you can go to the same website and search for MB1136. Let me show you. If we visit the STM's website, click on the search button and click MB1136. Okay, just click on that and you can scroll down and click on this link MB1136 default C05 board schematic. This will give you the schematic of the microcontroller board. Scroll down and here you can see the schematic of the microcontroller board. So what are the things that we have to observe? We can see PC13 is connected to the switch and by default the switch is open. That means by default PC13 is getting VDD, that is voltage, high voltage. So by default the PC13 is high, and when we press the switch, the voltage at PC13 will go to ground. So when the switch is not pressed, PC13 is high, and when the switch is pressed, PC13 becomes low. Please make note of this particular behavior. By default, PC13 is high. When the switch is pressed, PC13 becomes 0. Second, we can see from the schematic that the onboard LED LD2, so LD2 here is connected to D13. Okay, D13. You can see here green LED LD2 is connected to D13. So if you go up, you can see D13 is connected to PA5. Okay, so PA5 is connected to D13 and D13 is connected to our LD2, which is our onboard LED. So make note of these two things and then we can start the Cube IDE. So let me open the IDE and we will follow the same approach to create a new project, and then we will write our own code to make the LED on or off depending on the status of the switch. So let me go to File, click New and STM32 project. It will take maybe a couple of seconds to open the IDE with all the definitions. So we have to wait for a couple of seconds. So it is initializing the target selector. Okay, we will go to the board selector. And in the board selector, we will write F446RE. So Nucleo-F446RE. And here is our board on the right, bottom right. Okay, click Next. Then give a name to the project. So let me give it a name switch underscore and underscore LED and click Finish. So it says initialize all peripherals with their default mode. I don't want to initialize all the peripherals with the default mode. This will open the IDE in CubeMX mode or CubeMX perspective. If you recall, there are three perspectives in which we can work with the STM Cube IDE. One is your CubeMX perspective, second is C and C++ perspective, and third is debug perspective. Okay, so it is taking a bit of time to open the project. So we have to wait because it seems the project IDE is updating few things and downloading few things from the website. That's why it is taking time. Okay, so here we have the CubeMX perspective. We can go to pin out and clear all the pins. So yes, now we can start writing the code from scratch. So if you recall, PA5 is the pin to which the LED is connected. So we have to click on that, left click, and then make it GPIO output because LED is going to work as an output pin. Then right click on that and enter user label. Let me give it a name LED. So PA5 has been configured as LED. Now going to PC13, because we are going to use switch, so we will configure it as an GPIO input port. Right click and let us give it a name VUTTON button, or you can give any name that you like. Done. So we have configured the LED or PA5 as an output port, given the name LED. PC13 is configured as the input and given the name button. In the system core, if you want, you can configure serial wire, and by right now I am not configuring anything. Second job is to configure the clocks. I am not changing anything here. I'm leaving it in the same default configuration. And now I can click on this geared button to generate the code, or I can use save all option. I prefer to go for save all option. It will generate a message. Do you want to generate the code? Yes, I want to generate the code. I click yes. Now the second perspective is our C and C++ perspective. Seems the software is downloading few things. That's why it is taking some time. Okay, now we have the main.c file where we will have to modify the code. If you see in the main file, the microcontroller or the CubeMX has already configured the system clock. It has already configured the GPIO. And if you come down here, we have the main in which all has been initialized, system clock configuration has been initialized, GPIO has been initialized, and we have the while which is empty. And then clock configuration, you can see all the configuration settings for the clock. Because we are not going to change it, I will close this part. Similarly, for the GPIO, the configurations are provided here. LED GPIO port. Port's name is LED GPIO port, and pin name is LED pin. Similarly, if you see here, button pin and button GPIO port. So the port name is button GPIO port, pin name is button pin. So we don't have to change anything here. So I will close this part also. And now we have to write our own code. So click on the drivers. Click on STM32 all drivers. Click on the source folder where you get the C files. Open the all gpio.c. Double click on that. In the right side, you can see the outline where we get all the functions related to the GPIO. Now our task is to read the status of the switch, and based on that we have to make the LED on or off. So we'll be using these two functions, GPIO read and GPIO write. So let me first read function. So I will just copy this part, okay, and paste it in our main file. If you can recall, remember to enter all the codes in this section, user code begin and user code end. Otherwise, if you write anything in this region which is outside user code, then whenever you make any changes in the CubeMX in the future and regenerate the code, all the codes will be cleared or deleted by the software. So please take care of this. So I will paste the function here, and because we are reading the port, which port you are reading. Okay, so we have to write which port we are reading. So here we are reading the button port. Button. I will press Control space to give me the options. Button GPIO port, and which pin are we going to read? So GPIO pin. So BUTT button pin. So we read this pin, but what to do after reading it? So what I will do is I will save this value of the status of the button on a variable. So let me call the variable swrtch switch underscore state is equal to all. So I have not declared any variable which is switch state. I will declare this variable in the user code or user private variables section. So user begin private variable, I will just make int underscore wait uint underscore 32t unsigned 32-bit integer switch state. This has been declared, not initialized. Okay, so the value of the status of the button pin will be stored in this switch state. Now what I need to do is I need to check if the switch state, okay, switch state is high or 1. In that case, we want to write high or low on the LED pin. So I will use the write function. So copy this function and paste it here inside the if statement. Now let us configure the function. So first argument is to provide the port GPIO X. So I will use LED GPIO port. Okay, which pin we want to work with? We want to work with LED pin. So this is the LED pin. And what is the pin state? If you have any doubt in this particular variable, okay, then open the gpio.c file, and here you can see we have two options for the pin state. One is the GPIO pin reset state, which will make it 0, or GPIO pin set state, which will make it high. Okay, so you can use either GPIO pin reset or GPIO pin set. Now here we have to recall, by default the pin is always open. That means the pin is always high. So if the switch is always high, from the schematic if you recall, the switch is always high. So if it is unpressed, the switch is always high. So if it is high, I want to make the LED low. So for that I will use GPIO pin reset. So when the switch is high, I want to make this LED's pin reset. That will be off. Now if the switch is pressed, what will happen if the switch is pressed? If the switch is pressed, in that case I will go for else. Okay, if the switch is pressed, then the state of the switch becomes 0. For that I want to make the LED on. So I will copy this, I'll paste it here, and instead of reset I will make it set. Okay, so this is our program. Now let us build the program and check if there is any error in the program. So we can see here we compiled the program without any error or warning. Okay, so we just declared a variable and stored the status of our button on that variable. If the button is high, by default the button is always high. We have checked it from the schematic. If the button is unpressed, then the button is high, and therefore I want to make the LED off. And when the switch is pressed, it goes to 0, or the switch state becomes 0. In that case I want to make the LED on. So this is our code. So let me now go to the debug mode, and for that I will click on the bug and click OK. Now we will enter into the debug perspective, and if you can recall, in the debug perspective we can run the code line by line and see the effect of each function or each code step by step. Okay, so here are the buttons: terminate and relaunch if you want to close the program and relaunch the debugging. Here resume, it will run the program in one go. Stop debugging, step by step, line by line if you want to enter the code, or step over, that means function by function if you want to execute the code. So let me just open my camera and show what happens when we execute the code step by step. for that. Give me a second. I just let me open the camera. I hope you can see the camera, and let me go function by function. So all init has been executed. System clock configuration has been executed. GPIO initialization has been done. And now let me execute the code. Switch state is equal to all GPIO read pin. And now you can see we have entered into that section. And if you want to check the status of the variables, then you can just open the live expression, or you can go to window, show view, and then in this you can open expressions. And in the expression you can add new expression. Click on that and just write the variable which you want to see. For example, switch underscore state. Enter. And you can see the value is 1. So that means by default the status is high. If the status is high, then in that case the LED is reset. Let us check. And you can see the LED is off. So in this way, if the switch is unpressed, the LED will remain off. But when I will press the switch, the state will become 0, and that will make the LED on. Let me make the switch pressed, and then let me go to function, and you can see the state becomes 0. Therefore, we will enter into the next else statement, which makes the LED set, and you can see the LED became set. In this way, we can execute the program step by step, and once we are satisfied with the program, we can click here, resume. This will make the program run, and I can click the button, and whenever I press the button, the LED is on, off, on, off, on, off. So this way you can write your code to make the LEDs on or off depending on your choice. So with this, I would like to end this video. If you have any doubts or suggestions or queries related to the program, you can post your doubts or suggestions in the comment section. If you have not subscribed my channel, then I would request you to please subscribe the channel and share the video with your friends. Thank you and have a nice day.